Добрый день.
Good afternoon, dear colleagues and guests. Today is the 16th of May 2022, 3 p.m. Moscow time. Let me declare open a session of the Dissertation Council for the defense of thesis by Iurev, Gleb, Olegovich for degree of Candidate of Chemical Sciences, specialty 1-415, solid state chemistry, on the topics synthesis of composites based on carbon nanostructures and silica, investigation of their physicochemical and biomedical properties. By the order of the Academic Secretary of St. Petersburg University, Alexander Valentinovich Gniotov, dated the 10th of March 2022, number 2098/1, Ms. Zvereva Irina Alexeyevna, Doctor of Chemistry, Professor of the Department of Chemical Thermodynamics and Kinetics, was appointed Chairman of this Dissertation Council. Other members of the Council were appointed with the same order. Let me introduce them to you. Tolstoy Valery Pavlovich, Doctor of Chemistry, Senior Researcher, Professor, Department of Solid State Chemistry of St. Petersburg University. Korolov Dmitry Vladimirovich, Doctor of Chemistry, Head of Nanotechnology Research Laboratory, Center for Experimental Biomodeling, Institute of Experimental Medicine, Almazov National Medical Research Center. Maligin Anatoly Alexeyevich, Doctor of Chemical Sciences, Professor, Head of the Department of Chemical Nanotechnology and Electronic Materials of St. Petersburg State University of Technology, the Technical University. Shilova Olga Alexeyevna, Doctor of Chemistry, Chief Researcher of the Order of the Red Banner of Labor, Grebenshikov Institute of Silicate Chemistry, Russian Academy of Sciences. In the remote interactive mode, we have Smirnov Vladimir Mikhailovich, Doctor of Chemistry, Professor of the Department of Solid State Chemistry of St. Petersburg University. Vladimir Mikhailovich, can you see and hear us? Yes, I can see and hear you. Very well. Poklonsky Nikolai Alexandrovich, Doctor of Physical and Mathematical Sciences, corresponding member of the National Academy of Sciences of the Republic of Belarus, Professor of the Department of Semiconductor and Nanoelectronics of Belarusian State University. Nikolai Alexandrovich, can you see and hear us? Yes, I can see and hear you well. That's good. Let me introduce the applicant to you, Iurev Gleb Olegovich. Also, the thesis supervisor, Doctor of Chemistry, Associate Professor of the Solid State Chemistry Department of St. Petersburg University, Postnov Viktor Nikolaevich. Thank you. Let me inform you that our session is being recorded and broadcast live at St. Petersburg University website. These pictures are being simultaneously translated from Russian into English. During the live broadcast, an email is displayed to which, during this session, all the listeners may send questions to the applicant or opinions regarding the content of the thesis and the applicant's speech and the ongoing scientific discussion. That way they will participate in the discussion. These questions shall be forwarded to me by our technical support department, and I shall present them during the discussion. Questions should be related strictly to the applicant's speech and the content of his thesis. It is necessary to indicate full name, position, and place of employment of the author. Questions that are not related to the scientific discussion and anonymous questions shall not be presented. In accordance with the order of awarding at St. Petersburg University academic degrees of Candidate of Sciences and Doctor of Sciences, approved by the local regulations of St. Petersburg University, hereinafter referred to as the order. A session. Dear colleagues, please switch off your mobile phones. Dear guests and dear council members, thank you for your understanding. Let me continue. In accordance with the local regulations of St. Petersburg University, a session of the council shall be considered competent if at least 2/3 of the council members are present, but not less than 4 persons. Our council consists of 7 persons, and all 7 are present, including Vladimir Mikhailovich Smirnov and Alexander Nikolaevich Polonsky in the remote mode. Nikolai Alexandrovich, I beg your pardon. I invite the Dissertation Council Activity Support Department officer to draw up the attendance list. Very well. Let me set forth the following procedure of today's session of the Council with the total duration of approximately 2 hours. Let me read aloud the procedure. Summary report of the chairman about the applicant and documents submitted by the applicant and their compliance with the applicable regulations. Answers to possible questions, approximately 5 minutes. Summary report of the applicant, approximately 15 minutes. Questions to the applicant strictly related to his report, not more than 2 minutes per one question. Answers of the applicant, not more than 5 minutes. Speeches of all the council members in turn, with their assessment of the thesis and the applicant's speech, as well as their questions and suggestions to the applicant, approximately 10 minutes for each speaker. Speech of the chairman with her assessment, that should also take 10 minutes. Next, answers of the applicant to questions and comments made by the council members, not more than 10 minutes. Open discussion. Speeches of the attendees with summaries of their report, summaries of their opinions, and on the thesis and the applicant's presentation, no more than 2 minutes. At that, all the speakers are kindly requested to register and fully introduce themselves before speaking, giving their full name and title. Next, presentation of questions to the applicant received during the discussion, during the live broadcast of the council session. Let me inform you that written questions, the presentation of which takes over 2 minutes, shall not be presented. The questions should be brief. Answers of the applicant, not more than 2 minutes for each question. Speech of the thesis supervisor, not more than 3 minutes. Discussion by the council members before voting of the defense results. For that period, sound shall be switched off. Open individual voting, with subsequent recording the results in the session minutes. Making decision on awarding, not awarding the degree. Closing remarks of the applicant, no more than 2 minutes. Dear colleagues, do you have any questions or objections to this procedure? If you have no objections, let's start the session. First of all, once again, please make sure your mobile phones are off. Let's start the session. Summary report of the chairman. The thesis by Iurev, Gleb, Olegovich for the degree of candidate of chemistry. Specialty 1 415, solid state chemistry, on the topic synthesis of composites based on carbon nanostructures and silica, investigation of their physicochemical and biomedical properties, was accepted for defense by the order of the Academic Secretary of St. Petersburg University, dated on the 18th of February 2021, order number 1364/1. Iurev Gleb wrote his thesis at St. Petersburg University as a postgraduate student. His thesis supervisor is postdoc Viktor Nikolaevich. I have introduced him to you. The number of publications which set forth the key results of the thesis according to the enclosed list is 7, including peer-reviewed journals from the list approved by the Ministry of Science and Education of Russia, 1 publication in the indexed scientific databases Web of Science and Scopus, 4 publications, and 2 patents of Russia. All the documents submitted by the applicant, according to the information I received from the curator, comply with the St. Petersburg University requirements and are kept at the applicant's attestation file. Copies are also available from the Dissertation Council Activity Support Department officer, who is now present at the session, Natalia Yurievna. Before I give the floor to the applicant, I have the question for the council members. Dear council members, do you have any general questions regarding the list of documents, and is it necessary to review the entire list of documents submitted by the applicant? No. Thank you. Then let us proceed to the applicant's presentation. Gleb Olegovich, the floor is yours. Good afternoon, dear Chairman, dear Council members, and all the attendees. Let me start my presentation. Amorphous silica and carbon nanostructures have a high specific surface area and can be chemically modified, which makes them suitable for use as sorbents, chromatographic materials, and drug carriers. Fullerenes have a number of unique properties that can, due to their practical application, since they have anti-oxidation and antiviral properties. Carbon nanotubes have high absorption activity, which allows to consider them as a base for composites, chromatographic materials. These facts determine the relevance of my research in the field of synthesis of composites based on silicon dioxide and carbon nanostructures. The aim of this paper is synthesis and the study of properties of obtained composites and water-soluble, and creation of sorbents for chromatographic separation and for hemoperfusion, and to deliver biologically active substances. So these determine the structure of my work, which includes the study of silica and composite sorbents, was carried out, modified with nano and creation of hammer-coated material, and composites and fullerene water-soluble derivatives. To identify the properties, we use the following methods: microscopy RPS, low absorption, thermo and fluorimetride, and hemolytic activity, antioxidation activity, and since fullerenes have unique properties, they are of interest to be used in medicine. This explains the relevance of obtaining fullerenes of particular frequency, getting a high frequency of specific fullerenes for pyridyl phase, which is a problem. And so in order to solve this problem, we synthesized a number of sorbents. The synthesis of these composite materials was performed as follows. Carbon nanotubes were milled, then added resil was added, and dry milled, then the water was added, and water milling was conducted, which resulted in gel, which was dried, and as a result we obtained the necessary fraction. The heating, the firing, was conducted to strengthen the structure and to remove oxygen-containing structures from the surface of carbon nanotubes. In this slide you may see microphotographs taken for delta, MWNTC, as well as aerosol. And the following micrographs show that after the mechanical treatment, the carbon nanotubes are folded into balls. But when composites are produced, the structure changes significantly. Globular silica particles form a compact nanostructured material with carbon nanotubes. After calcination, these structures appear in the composite samples. In order to have a more complete picture of the sorbents obtained, studies were carried out using a set of physicochemical methods of analysis. And it becomes obvious that for Bayer nanotubes there's no breathing mode, and the relation of bands indicates the carbon nanotubes are defective, and the intensity ratio of these bands changes slightly, indicating a tendency for the structure to become more defective during the mechanical treatment. Also, thermograms and absorption isotherms were obtained. The method of insertion of silica dioxide. So this conclusion was made as we analyzed the thermograms, 500-700 degrees Celsius, which also corresponds to burnout of the entire sample mass. As for the fourth type isotherms, according to Brennauer classification, such isotherms are characteristics of mesoporous solids. Aerosol in itself is not capable of carrying out the chromatographic separation of fullerenes. The data allowed us to conclude that best results are observed on, especially with composites M, N, and T Bayer. It should be noted that Taunid nanotubes has the best result, is domestically produced product, which suggests a full-fledged input substitution. Thus, it's necessary to note that such composites can be used for chromatographic separation of fullerenes. And the work is focused on assessing the possibility of using the composites synthesized for the first time in a wide range of different areas of science. In biomedicine, as hemosorbents, solid drug carriers, and antioxidants. One of the areas in which such composites can be used is hemosorption. This procedure allows the treatment of limb pathologies of varying degrees of severity. The carbon sorbents used in practice have a number of drawbacks, such as brittleness, and hemosorbents can result in vessel congestion. That is why the synthesis of hemosorbents with the necessary sorption properties is highly relevant. And in order to solve this problem, we synthesized two composites to synthesize carboxylochrome. On the surface of carboxylochrome C120, we applied a layer, and to obtain carboxylochrome C60 was modified by fullerene by its sorption from the solution. This slide shows microphotographs, RPF spectrum, and a pore size distribution for obtained sorbents. Comparison of the microphotographs shows that there are no significant changes in the surface morphology. It should be noted that modifying the surface with fullerene only slightly changes the absorption. You may see the peaks that correspond to 500 and 103 electron volt binding energies. Distribution of C60 indicates that the pore size has changed on this lab from 31 to 28 nanometers. Further studies showed modification of the surface leads to a significant change in properties, and one of the main properties is how it affects hemolysis, so the process of erythrocyte destruction. And in order to assess these changes after interaction with sorbents over different periods of time, best results were carboxylochrome C60, which after 60 minutes of contact did not cause significant hemolysis. As you can see, the peak corresponds to hemoglobin released from destroyed erythrocytes. So here it stays at its minimum. Thus, a sorbent was synthesized that didn't undergo fullerene distortion and had good hemocompatibility, as well as high stability, mechanical stability. Aerosil is widely used in medical practice, and one of the spheres is creation of composite materials on its basis and different types of medicine. Fullerene, as we have just mentioned, it can be used in biomedicine, and because of that it was interesting to synthesize composites with aerosil and its water-soluble derivatives. So solid, liquid state. After that, hemosorption from the solution was performed. The of carboxyfullerene and aerosil is shown in the next slide. This slide demonstrates the sorption properties, and as you may see from the results, the maximum content is for carboxylized fullerene. So it was decided to study its biological and physical properties because it's best studied of carboxyfullerene to be used in practice. The study of the photographs demonstrates that there are no significant morphological changes. Absorption corresponds to class 4. Pore diameter is up to 28 nanometers, and from RTS spectrum it demonstrates that this 103, which corresponds to oxygen, carbon and silica. So we may conclude that the surface of silica dioxide is modified with oxygen containing material. The biological study started with the study of particle sizes, water dispersed and water solutions, and the calculation of their potential. As for carboxylated fullerene, it corresponds at the same time with associate of the first and the second type, which correspond to the 50-70 nanometers and to high concentrations of as for composite, the presence of the following substance was identified, and in this sphere of high concentrations, zeta potential is one of the most important characteristics for colloid dispersed systems. That is why the following studies, we conducted more studies. The value of potential is 20 millivolt and higher. This is stable. So for carboxylated fullerene, we may see that it's from -60 for zeta potential for various associates. As for composites, it stays at approximately 20 millivolts, which enables us to talk about. So thus we may register different sizes of carboxylated fullerene, which is important for addressed or targeted delivery, because it takes into account the blood vessel diameter. As was mentioned earlier, fullerene has, we decided to study it as well. For that, we studied the anti-radical action of this slide shows the hypothetical mechanism of this reaction, the fast stage and the slow stage. According to the results, we calculated the amount of restored and for composite amounts to 15.8%. Also, we conducted studies of photohemolysis and results of photodiscoloration with the use of composite material occurs. The photodegradation process is slowed down. As for photohemolysis, the composite would increase the time of decomposition of erythrocytes with and after radiation. The composite have antioxidating properties, has transport functions. That is why we studied process connected with, on the basis of human albumin. Results indicate that there is bonding in a fairly tight complex, and which indicates that albumin can play its transport functions in the blood stream of that composites. Also, we studied the process of IATF-induced erythrocytes, and the results indicate that carboxyfullerene has the non-dose dependent effect, and by adding composite to blood plasma with thrombocytes is anti property up to 100 concentration of 100 micromole. So by entering carboxyl, we reduce pro-aggregant effect. Also, we studied the activity, which allows us to conclude that the time of hemolysis depends on incubation time and dosage. This doesn't play any significant role, because in this case, according to the regulation, hemocompatibility to the material, the hemolysis of which does not exceed 5%. So here we have approximately 5% at best. So these two materials are compatible with that. We have also studied cytotoxicity on human embryonic survival. So we found, with a concentration of carboxylated fullerene, cell survival. Carboxyfullerene and composite doesn't have these properties, so we can reduce the toxic effect of individual carboxyfullerene. Thus, we synthesized composite on the base of aryl, which had high hemocompatibility, antioxidation properties, anti-aggregation properties, and this can be seen as a desensitivizer and carrier for targeted delivery. In this slide, you may see the conclusions, and there's another slide with a list of my publications and conferences I have attended where I made presentations. Thank you. Thank you, Gleb Olegovich. Dear Council members, do you have any questions to the presentation? Anatoly Alexeyevich, I don't have to introduce me. I am Anatoly Alexeyevich Maligin. I have several questions. First, how would you assess the mechanical essence of the sorbents? You used this expression a lot. In what units did you measure? And the mechanical strength, why would it go up? So that's how the experiment was conducted. We took small solution of erythrocytes, so then kept it at 37 degrees, removed the erythrocytes, and and what erythrocytes left after hemolysis. And then we conducted the visual examination of the remaining plasma, where we found never odd particles. I don't understand. So the mechanical strength. So that's mechanical. You said mechanical strength or stability of the material. Where is mechanical stability in that? It's usually examined by milling. I mean mechanical strength for hemosorption, because so we found that small particles get back into the bloodstream. So you looked at, so we didn't use the classical method. We looked at particles necessary. And I have one more question, please. You mentioned many different properties, hemolytic activity and others. What are the reasons for that? Can you look at an example, give an example, and discuss it, like how hemolytic strength or activity increased? Not just state it, but explain why, explain the mechanism, why it happened. As we believe in the carboxylochrome and carboxylochrome 60, the surface of carboxylochrome, if you look at this figure here, the mechanical electrolytes damage the membrane, so which starts this hemolysis process. And when fullerene 60, when it is absorbed, it smooths these sharp edges that can damage the membrane. Thank you. Does anybody else have the question? Olga Alexeyevna, please tell me. I have a question. While reading your thesis, I could not understand. Now I got Zol-gel technology. You are not using the classical variant of this technology, and I understand that as mechano activation you're talking. So you grind an aerosil and 2 Zol. But so these are elements of this technology. But in the classical variant, I could not find it, and I even wrote a comment about that. And now I have the second question. Figure 19, slide 19. You have quite a fascinating scheme. May I show? So please explain what does that mean, and why have you made these curves? Why have you put these curves? Why not straight? Why do they look like that? So could you please explain more? What does that mean? Let me start with the first question about Zol-gel technology. The matter is that first we conducted this mechanochemical treatment. So the large fraction was milled to put it more evenly into silica nanotubes. And then we added water, and in the end of this processing we obtained some sort of gel, which even visually it looked like gel. And then we dried it, and so then we but you wouldn't call this a full method, Zol-gel technology, but after, so we got something similar to gel substance, so which later we treated. So this is synthesis which goes through gel location. And your second question about those concentration relationships. So here a wide range of concentrations was used, and of course a wide range of aggregate sizes. And because of that, we decided to use such a logarithmic processing, because it allowed us to reduce this schedule, because there would be large gaps in the sphere of small concentrations. So that would be 50 to 57 particles, and so that would be impossible to show in one picture. And such form of figures, they're quite common in articles in chemistry and physics, but I don't understand the significance of these curves. Do they depict relations? In this case, these curves depict, they can look anything they like. They simply say that we can observe joint present of the second and third type associates. So joint present at certain concentrations. So you put them into groups, right? So if you had dots, so that's purely visual. So for to make it easier, so you group them. Yes, thank you. Boris Vladimirovich. Gleb Olegovich, here's my question. In slide 6, in the bottom left corner, you have a nice structural formula of what you obtained. Have you actually checked the presence of such bonds, or is it only suggested structure? You mean this structure? So this is the surface of silica surface, which indicates the possibility for modification. Have you investigated the bonds? How do they interact with silica molecules? Please answer. Can you answer this question? Dear colleagues, we have to take a technical break. Technical break number 1. Oh, he's back. Okay. So shall we close the technical break, or we have not started? Vladimir Mikhailovich, please stay with us. We have to see you. Otherwise, we'll have to take breaks. Yes, you mean if we studied the covalent interaction, the nature of bonds that are formed during the mechanosynthesis. The covalent interaction we have not studied, but we've studied with classical method of identification, Kaya spectrum, how is the surface of is closed. So here we have only 2, but of course we have much more. The nature of covalent interaction, this was not our primary task. Thank you. I have one more question, please. The hemolytic often is after 24 hours of incubation. You have not studied that. You've studied that only after 30, so maybe after 24 hours your material will not be biocompatible. What do you think? We have studied after 60 minutes of contact, maximum of carboxylochrome C60, and as for 24 hours, yes, I expect the hemolysis stage will be much higher, but hemosorption can be different in different time periods. So it's most likely that it won't be necessary to make it so long. Dmitry Vladimirovich has another question. I understood the answer. Well, please tell me. You have 2 mechanisms of anti-oxidation, and your material should be proton donor. So you only suggest this mechanism. Yes, you're only suggesting this mechanism. Yes, it's depicted here. So we expect there to be two parallel processes as to C bond or association. Let me carboxylized fullerene. Do council members working in the remote mode, do you have any questions? Nikolai Alexandrovich? I think I will ask my questions when it's time for me to present my review. Do you have any questions? I have a very small question, please, related to the question of Dmitry Vladimirovich about covalent. Cannot you obtain this information from an echo spectrum? That would indicate such covalent bonds. Here, as you may see, there are additional bands in the spectrum. So the spectrum is different in the spectrum. So something is happening, but as on the whole, as you can see, they are quite similar. Only the relation of intensity is changed. So there is some covalent interaction, of course. So maybe if you look up these new emerging peaks, perhaps you may come across something. If there are no further additional questions, I have a question, please. My question is, the work has so many components, so I won't look into details, but I have a question about the sorption materials. We have solid chemical compound, which is also material when it has certain functional properties, and normally is desirable to compare it with at least one Russian or foreign material sorption to see that the author has synthesized material of good quality, but I haven't seen such a comparison in the thesis and in your presentation. So how can you talk about some material? I'm not talking. So it's very complicated. But of the sorption properties in a thesis, you can easily obtain data and compare it with any data available. Vladimir Mikhailovich, thank you very much for your question. Is the question clear to you? Yes, of course. So please answer. The matter is that in order to compare with any standard world-known materials, we need to reproduce the same conditions. And since is impossible to determine at what conditions results were obtained, is impossible to compare using or considering this the impossibility to reproduce the conditions, but it's possible to evaluate the yields. And the work Yelena Naumovcha, also a postdoctoral student, she studied this fullerene division process, the alkene phase, where C70 fullerene yield was as high as 94%. And here our result with Townite tubes was C70 is 92%. So if we look at yields, not considering the conditions at which it was created, so we are 2% below. But Taunit, these are national tubes, inexpensive, easy to make. So thus we may say that in this case, so this result is better. And as for example, hemosorbents, especially in this case, so they are mechanically unstable, so which is a huge drawback. And so in some cases it's advisable not to use them. So here the compatibility is good and the mechanical stability necessary for hemosorption. Thank you. Vladimir Mikhailovich, are you agree? Do you agree? Yes, I agree. If there are no further questions, then let us proceed to council member speeches and their reviews with assessment of the thesis and the applicant's speech, with questions and suggestions to the applicant. And the chairman will also present external reviews, if any. Let me remind you that the applicant has to answer each reviewer individually. I suggest that you answer questions and suggestions right after the review is presented. Yes, thank you. Is that okay? Yes. So which order? I suggest we start with Vladimir Mikhailovich. Vladimir Mikhailovich, are you ready? Can you start? Yes, I'm ready. And then we'll continue. And Nikolai Alexandrovich will be the last one. I read the thesis and I liked it. And I made some comments which I have already asked my questions. That is why I think I've performed my duties as a member of the council, and I liked the work. That's all. Do you have any? What about the questions? But I see. My question is, I have just asked my question, and the applicant gave an exhaustive answer, comprehensive answer. Then, Valery Pavlovich, the floor is yours. Thank you for given the opportunity to speak and to share my impression of the thesis after having studied it carefully. First of all, I'd like to drop the part on relevance and practical significance. I think from the report we have just heard, everybody got the impression, the positive impression. So let me proceed to specific remarks. First of all, I noticed that first three conclusions say that new methods have been developed. At that, in the list of publications, there are two patents called synthesis methods. So here, I think the applicant has deliberately the new methods, but not the methodology, but new methods were created. This is important because in the specialty passport, the candidate's thesis necessary to create new methods of synthesis. This is my first comment. My second comment is I noticed that provisions submitted for defense are of they look like statement, and the essence is not explained. And I think this circumstance slightly affects the overall impression. So the thesis would look better if each provision you explain the essence. For example, this compound interacts with the other compound, and so in these conclusions, so you need they lack some specific information and some numbers. And my third comment is about presentation of the thesis. Practically all the figures related to Romanov spectrum, they show some relations, but the wave numbers are not given. So that is such a drawback of presentation, because in the text of the thesis all these values are given. So it would be more it would be easier to see if you demonstrated it with illustrations. But I think the work corresponds to the requirements, the specialty solid state chemistry. Thank you for your attention. Thank you, Valery Pavlovich. Next, let me give the floor to let me answer the questions. As for the first comment, of course I agree with it, and in that case by development we mean methods of synthesis. Indeed, so we have developed them. As for conclusions, the matter is that results of many such studies require long explanations, so it was hard to summarize them in short conclusions, all the results described in the text of the thesis. And as for the third remark, I agree that the text does not include these parameters, but I have taken this into account and included all the numbers, all the peak numbers in the illustrations. Valery Pavlovich, are you satisfied? Thank you. Dmitry Vladimirovich, the floor is yours. Dear colleagues, in my review I gave a short overview of fields of science and technology where nanotubes are used, and there is a trend of using nanomaterials in medicine. So the work is relevant. It was tested at 8 conferences. The author published 5 articles, some in highly rated journals. So the practical significance is confirmed with 2 invention patents. The main results and the main conclusions are well formulated, at least I think so. My questions I asked right after the presentation, and I got comprehensive answers. I only had one comment. The goal and objectives are usually given after the analytical overview on the basis of facts, but in this work goal and objectives are given in the introduction. So I think it would be more appropriate to present them after literature overview. But apart from that, I support awarding the degree to Gleb Olegovich of the degree specialty. As for your remark, such structure is because there was no auto. That's a requirement. So it became traditional. So now it's given in the introduction. Oh, I see. Thank you very much. Anatoly Alexeyevich. Good afternoon, dear colleagues. We see each other so seldom these days. As for the work under discussion, as for relevance and practical significance, I think everything is very simple here. The object of the study is and hybrid materials and assessment of fields of potential use is beyond any doubt. And the speaker in his presentation and the patents obtained by the applicant. So, of course, as my other colleagues, I would dwell more on my comments. I have 4 of them. So here, these are my comments. First, large part of the study, but in some cases, there's no full explanation. As for new synthesis methods, and an explanation of synthesis regimes, the choice of methods of study. So such justification was insufficient. Second, there are many figures in the text of the thesis. A book with illustrations is always more interesting, but here, for example, I think this is too much. For example, in section 3.1 from pages 56 to 80, there are 41 illustrations. It would be useful to put them in the annex and maybe devote more space to explanation. Third, is necessary to analyze the mechanical chemical treatment of carbon nanotubes. This was already mentioned today. I think maybe the only thing I think is incorrect to say that milling of nano, which has nano content. So what can be milled? But that's all. It's all about the use of terms that I mentioned already to the colleagues. I think the method of chemical assembly. There are many different. So it would be chemical. A method shouldn't be called assembly. It's a group of methods. So chemical assembly was conducted with this method. I paid attention to this in some articles. And my 4th comment, there's a number of typos. For example, on page 21, author who created the molecular layering. And a group of our colleagues, Evgeny Smirnov, Alexovsky, Kapelov, Koltsov, and further the references 8791, and then the method of chemical assembly. It was 8791, but these references do not fully reflect the essence of the statement and not publications of named authors. The names are not given, but these remarks of course are maybe in some cases these are only points for discussion. And I actually got answers to some of them. So the work leaves a very favorable impression. Its medical focus, human health focus is very good. And I think that Gleb Olegovich, Iurev, deserves awarding the degree of candidate of chemistry, which corresponds to the order of which explains the validity of awarding the degree. Thank you. So do you need answers to your questions? So maybe about the chemical assembly, maybe, and references and raw references. Are these typos? Yes, about the chemical assembly, I agree that this is about the use of terms. It seems to be a very broad term which can be used for applied to methods I used in my work for multi-stage synthesis for these organic compounds. As for the references. Let me read the title. So it should be on various porous structure, authored by Smirnov, a couple of Sorbents. So here I made a mistake. I beg your pardon. Olga Alexeyevna, your review, please. Thank you. I wanted to say that it's a pleasure to see all of you. And as for the thesis, of course, I can join to what has already been said. The topic is relevant, and a big study has been conducted. And as for today's session, I think the applicant's presentation made a good presentation and gave good answers, and which unfortunately I cannot say about the presentation of the thesis. And I expected to see a very young and inexperienced man who doesn't know how to present papers. Maybe you were short of time or something, because their presentation of results, huge pictures, so the no lack captions or captions, different pictures. So such, I was very irritated by this when reading the work. And also it's very fashionable to talk about the list of literature. So I will also say that if we look at the Russian journal, Russian magazine, should refer to the Russian version. But you and maybe not all cannot put so it's too much variations, but on the other hand, maybe it would be good to see a more detailed description of some procedures, because the synthesis itself was not very clearly described, or maybe such processes as polymerization with fullerenes and amino acids. So it would be interesting to see some references. But in generally speaking, I agree that the work is interesting, and I like the presentation and answers to your questions. I can see you know your subject, and I think you deserve awarding the degree. So maybe I don't expect any answers, or maybe some comments. Nikolai Alexandrovich Poklonsky, your review, please. Thank you. The subject of the thesis is relevant, especially the part on water-soluble fullerenes. At our university, we had some projects within the Horizon program where water-soluble fullerenes were to be used in Alzheimer's disease and Parkinson's disease treatment. And the main question on how to find the interaction between symmetric and fullerenes and the possibility of adduct removal. So that is a problem. And the thesis touches upon these issues. The second thing I liked is the synthesis of carbon sorbents. The hydrocarbon grade is a mechanochemical treatment. He obtained first Zol, then added water and obtained gel. And usually this technology is implemented as followed. Oil is evaporated until and in the end we get quartz glass, which we use for various purposes. So the method and the topic of the work appears to be highly relevant and significant. I will not talk about the validity, which is confirmed with numerous methods used by the applicant and quite with some success. Results were presented at conferences and in magazines, and I agree that Russian magazine should be, and then translation should be given afterwards in brackets, and Russian publication should be given first. I made 8 comments, but some comments have already been answered. But the provisions submitted for defense according to the requirements of our attestation committee is that is necessary to explain the reason why this happens, not just observe phenomena, but if possible explain the reasons. In some places the reason has been explained, and I'm not going to talk about the typos, and my comments do not affect the overall positive assessment of the thesis as a whole. So here I have listed why the degree should be awarded to the applicant of the degree of candidate of chemistry for the results which make a significant contribution on the basis of composites, so silica and carbohydrate nanostructures. These were all so this field, of course, is very important, and hopefully it will develop in St. Petersburg. So that's all I had to say. Thank you, Nikolai Alexandrovich. Would you like to answer? Yes, thank you for such a review. Indeed, not everywhere the results were given and some prerequisites, because in reality we conducted much more work when it's shown here, because this was a study, and in addition to positive results we also obtained negative results. So these we did not include. So, and a large part of, so we as for sorbents in my work, besides the only 2 sorbents, but in fact we synthesized 4, but 2 did not show good results. So that's just an example. It's only an example. So unfortunately we did not show everything. Thank you, Gleb Olegovich. Nikolai Alexandrovich, are you satisfied? Yes, I am fully satisfied. Dear colleagues, now it's my turn, but I would like to join all the positive comments in your reviews, because this work has great practical significance for solid state chemistry, and I'm happy I read this thesis, and I'm proud that at our institute, at Solid State Chemistry Department, such important work is carried out. Many thanks to your thesis supervisor, to the head of your department, that they are paying attention to this topic. So maybe only 2 points maybe have not been mentioned by other reviewers. First of all, of course, it's a huge experimental material, and the validity of experimental data is confirmed with the impressive facilities of our research park, and in the facilities in medical institutions where studies were conducted, such as Almazov Center and the first medical university. Of course, these results in combination with the physicochemical studies conducted at our university, these results deserve trust. And as a professor of thermodynamics, I want to comment on good use of a thermodynamic approach to some processes, such as interaction of aerosol with carboxylated fullerene. When it interacts will definitely get hydroxyl with biological preparation. Please remind me. Anti-radical activity, aerosol composite with which biological component. So here we had antioxidants, and then albumin, and human albumin, and the thermodynamic of hydrophobic interactions, and thermodynamic function of this process you also have, and that is fundamental. Such fundamental approach makes it more significant. I have not really critical remarks but questions, but I still have some, not a lot but some. First, the composites you have suggested, so you consider them they have potential for medicine delivery, but they are different from liposomal formula used for addressed delivery. Could you compare? Second question, you have studied the multi-layer nanotubes, and single-layer nanotubes have even greater surface area, so they should even be even superior. So can you compare why you decided to talk about multi-layer nanotubes? What else is there, do I have? Not all the composites with of hydrocarbon nanotubes, their absorption properties have not been studied, and the only critical remark that I have is about the presentation of the thesis. Is not quite clear. It's not clear why for one type of nanotubes synthesized the internal radius is smaller than the outer. Is this a typo? Is a misprint? Yes, of course that's a misprint. It should be the other way around. That's a very important parameter to which you certainly pay attention. And so then what would be your answers to the first three questions? So you, as for liposomal forms, they are widely used and have a number of advantages. For example, they have good ability to deliver to affected area. They can reduce toxicity. They can be resistant to acid environment if taken orally, but also they have a number of disadvantages, such as, for example, it's hard to preserve, to store. In some cases, the low degree of encapsulation of liposomes, you need higher dosage, and low take methods, and they're quite expensive. If we compare them with composites, we obtained, so first, these are high-tech, and relatively cheap and relatively easy to obtain, and they can be used for passive at rest delivery, because you can record the size of particles, and it's very important to consider that in the impacted areas is necessary to pay attention to size. And also, if we talk about composites, they are also biodegradable, so they and leave the body. So this is for the first question. And as for the second question about hydrogen, they are much more expensive, even though we have a company in Russia which set up production. It is more difficult to use, and irreversible absorption of fullerene C70 can occur. And our task was to separate, not to isolate, but because fullerene 60 is also very valuable. It's also a very valuable product. And as for your third question, not all sorbents have been studied as hemo preparations. See, many medical studies showed that nanotubes have a high hemolytic activity, which is most likely connected with open fragments, which can lead to hemolysis. And to increase this hemocompatibility, it's possible to use a chemical modification. So, for example, we have studied composites in chromatography. Thank you. I'm satisfied with the answers, and I would like to join the other council members in saying that the applicant certainly deserves awarding the degree in solid state chemistry. No, we have no external reviews, and none of the attendees is willing to speak. As you have questions? Igor Vasilievich Murin, professor, head of Department of Solid State Chemistry. Is a pleasure for me, and so biomedical is so, this field is very rewarding for me. Who's the founder of this field, the father of this field in solids and medical chemistry. His defense was also held here, and the thesis supervisor. I'd like to compliment Viktor Nikolaevich Posnov, ensured very smooth as the chemical content, very relevant, highly relevant chemical content, materials that could be used from the point of biomedical application. Usually is like sports, one discipline sportsman, and here is like so here we can count the use of so the applicant had to educate get education, and without a very significant contribution of our colleagues, and as Almazov Institute and other. So this material was presented in a very favorable way when council members said is the tasks, goals and objectives, where should we put them, in the beginning of the thesis or after each literature overview. You may use both, but here there are rules prescribed, our rules, but though I remember in the New Testament, not the man for Sabbath, but Sabbath for the man. So here our colleague from Minsk I'm so happy to see you at our council session once again. So how to present our literature. And I understand, so usually philologists, they try to use the Cyrillic alphabet even when there is a Turkic, and natural scientists, they try to use Latin everywhere. So today you can have different attitudes, different rules of presentation, but if I'm not wrong. So here we can look at this topic. So thank you very much. Thank you, Igor Vasilovich. So now we can give the floor to the thesis supervisor, Postnov Viktor Nikolaevich. Dear colleagues, let me just say a couple of words about the former postdoctoral student who slowly reached. So he came from the Technological Institute. There he wrote a work on synthesis of fullerene derivatives. So with this bias toward inclination towards organic chemistry, he came to our department, tryptophan, for example. So he wanted and actually did this for a long time, so which distracted him from his major topic. In the end, we managed to get him organized. He became familiar with the solid surface chemistry, and we got quite a good combination of these two fields. I think the work is, though it took many years, he could have written it much faster, but this reflects his personality. He took up one thing, and each time he wanted to achieve some practical results, and as a result, he got 2 patents. So I'm satisfied with his work. I think he deserves awarding the degree of candidate of chemical sciences in solid state chemistry. Thank you, Viktor Nikolaevich. Is anybody else willing to speak? Olga Alexeyevna, excuse my curiosity. It has traces of catalysts. How do you purify it somehow? Yeah, filtrate it. Yes, we discussed it. Indeed, it contains traces of catalysts. The tubes we obtained at our institute, yes, so we cleared them. Tubes we bought, we have not been cleared, but so we found that it's positive, and the presence of such catalysts had no effect at the result at all. So we have achieved the positive effect. So no further it made no further changes, no significant changes. Olga Alexeyevna, I think the material, it can get contaminated with cobalt, maybe other, if you separate, maybe, I don't know what kind of processes there are. The separation with no temperature impact is, so we might suggest that no obvious impact of catalysts, but actually that's a good question which could be studied. We could study in the future. So we ran into such difficulties. That's why I'm asking, if there are no further questions, let's finish our discussion and accepting questions. Then let's finish the discussion. We have not received any questions via email, so we have the right to stop accepting questions. The discussion was interesting. Before we sum it up and vote, I have a question for all the council members and the applicant. Do the council members and the applicant have any questions regarding the procedure of today's session and connected with the remote access mode? Vladimir Mikhailovich, do you have any objections? No. Or remarks? No. Thank you. Valery Pavlovich, I have no remarks. Dmitry Vladimirovich, I have no comments. I am like Vladimir Mikhailovich. Olga Alexeyevna, no, I don't have any comments. Alexander Nikolaevich, no comments. Thank you. Then let us proceed to the next item, which is voting. I also agree that we followed the procedure and all was done, everything was done properly. Let's proceed to voting. And I have to ask the question, dear colleagues, before we vote, we have the opportunity to take a break to discuss the results, and the sound shall be switched off. What do you think? Do we need such a closed session to discuss the results, or is everything clear? So broadcasting will be put on hold, but so do we need a break? No, we don't. No. Okay. If we don't need a break to discuss the results, we don't need a closed discussion, we can continue. So let's continue. Now is 4:29 Moscow time. I put the question of awarding to Iurev Gleb Olegovich the degree of Candidate of Chemistry, specialty 1415, solid state chemistry, to open individual vote. Let me emphasize that by voting for, every council member agrees that Article 11 of the order has not been violated, the applicant. Let me remind you that Article 11, in the thesis, the applicant shall refer to the author and/or the source of borrowed materials or individual results when using them, of scientific works performed by the applicant personally or in co-authorship. The applicant shall indicate this circumstance in the thesis. As I understand, so this, everybody mentioned that in his review. Let me remind you that a decision of the Dissertation Council on awarding the degree shall be considered positive if over a half, but not less than 3 council members vote for it, according to Article 17 of the Order on the Council for degree of Candidate of Science and Doctor of Science at St. Petersburg University. Thus, let me proceed to interviewing the council members Smirnov Vladimir Mikhailovich, your opinion. I am for awarding the degree of Candidate of Chemistry. Thank you. Council Member Tolstoy Valery Pavlovich, your opinion. I am for awarding the degree. Council Member Korolev Dmitry Vladimirovich. I am for awarding the degree of Candidate of Chemistry in Solid State Chemistry. Maligin Anatoly Alexeyevich. I support. I vote for. Council Member Shilova Olga Alexeyevna. I am also for awarding the degree. Thank you. Council Member Poklonsky Nikolai Alexandrovich, your opinion? I am for awarding the degree. Certainly. And me, Zvereva Irina Alexeyevna, the chairman, also think that Iurev Gleb Olegovich deserves awarding the degree, especially in solid state chemistry. Counting the votes and announcing the results. Thus, dear colleagues and guests, let me inform you that out of 7 council members present, 7 voted for, nobody voted against, and nobody abstained. Thus, their decision to award to Iurev Gleb Olegovich the degree of Candidate of Chemistry, specialty 1415, solid state chemistry, has been made. Gleb Olegovich, the floor is yours. First of all, let me thank you, dear colleagues, for taking part in this council, for assessing my work and giving your reviews. I'd like to thank my thesis supervisor who has been guiding me, and with his assistance I managed to write this work. Head of the solid state chemistry department, Igor Vasilyevich Murin, who has also guided, gave me pieces of advice, answered my questions, and on the basis of Almazov Institute, Sergei Ivanovich Kuznetsov conducted some studies which I also included in my thesis. Many thanks to the scientific centers of St. Petersburg University, because many studies were conducted there, and great thanks to the head of Department of Chemistry of First Medical University, who also assisted Vadim Vadimovich Sharov, professor of the Ageyev Sergei Vadimovich. These are all our colleagues, and all those who supported me in my work. Thank you very much. Thank you. Me, as a chairman, I would like to congratulate you, and I think all the council members would like to join and congratulate you. You certainly deserve the degree. Well, our session is now closed. Thank you, everybody, for your participation. Please stop the live broadcast.